For concept 3, number 5, it asks you to draw 3 force diagrams, and then you have to write the sum of forces, the equations, in the x and the y direction. So the first situation, it gives you an Atwood's lab type setting, and so there is friction, and the object would be accelerating, so that the system is accelerating, and since it's not moving up or down, the x or the y components are equal, and you have the block having force gravity on it, and then force normal for the third law pair, and then there's a little bit of friction going back, and then there's a string pulling it, so there's force tension in the other x direction. And so the equation for this would be the force normal equals the force gravity, since it's not going up or down, and then force tension is greater than the force friction. And so the next situation is a block on a ramp, and it's motionless, and since it's at an angle, you draw your force diagram at an angle. And the gravity is still pulling down straight, and so you have force gravity in the x, and then you have force gravity in the y, and then since it's motionless, all of the sides are going to be equal, and then you have the block having force normal going up, and then force friction is keeping it still also. So all of these are equal. And then the equation for this would be force gravity in the x direction is equal to force friction. And then the force gravity in the y direction going down is equal to the force normal. So this object is still. And then the last one, there's an object that is on that's being pulled. And since it's not really going up or down, the force gravity is going straight down, and then there's force normal, and then in this direction there's an object pulling at it at a 20-degree angle, and so there's force pull in the y, and then there's force pull in the x. And all of these are equal. So the equation for this one is force normal plus force pull y is equal to the force gravity, and then you have force pull in the x.